Can you describe your thesis in 2 minutes?
Hi, my name is Elvira de Lange. I work at the University of Neuchatel in Switzerland. Plants are frequently attacked by herbivorous insects, such as very hungry caterpillars. Plants cannot run away when they are attacked, but don't be mistaken. They are not at all defenseless. They have plenty of ways to protect themselves, for instance, by having thorns to make them difficult to eat. Also, they could produce toxins to kill the herbivores, or at least make them go away. Interestingly, plants could also produce odors when they are under attack. Can you recall the smell of cut grass? This is a typical odor of a wounded plant, and it can be used by the enemies of herbivores, predators such as lacewings, or in my case, parasitoid wasps, tiny wasps that lay eggs in very hungry caterpillars. The wasp larvae that emerge from these eggs consume the caterpillar from the inside, and once they've had enough, they dig their way out through the caterpillar skin, inevitably causing it to die. So you could say that when attacked, a plant can actively recruit a bodyguard. For my thesis, I studied a caterpillar that is an enormous pest of corn, each year causing billions worth of damage. Therefore, I went to Mexico, the country of origin of corn, and studied odor production and bodyguard attraction of teosinte, the wild ancestor of corn. What I found was that cultivated maize and wild teosinte both emit odors in response to caterpillar feeding. However, some wasp species prefer the odors of wild plants, indicating that cultivated plants might have lost part of their capacity to attract the wasps during domestication. Conserving wild teosinte is therefore important, for we could possibly use these plants to breed better resistance traits back into cultivated maize. Impossible to imagine how from a thick, tiny, dark grain our yellow, juicy corn cobs evolved, but by going back to its origin, we can obtain invaluable information on how to feed the world with corn in the future. The title of my thesis is Hidden Struggles for Survival, Plant-Insect Interactions in Corn and its Wild Ancestor teosinte.